In this video, I want to discuss some ways that we can make comparisons across observations. Rates and ratios are ways of making comparisons between numbers more meaningful. The ratio is a fraction that describes the relative difference in size between two groups. Going back to the gender example from the Canadian census, we know that in Canada in 2006 there were about 161 females for every 155 males. Evaluating the fraction lets us figure out by exactly what percentage there were more females than males. In this case, we divide 161 by 155 and get 1.038. So if we're saying that 161 to 155 is the same as 1.038 to 1. So we're saying that 161 to 155 is the same as 1.038 to 1. By subtracting the 1 and multiplying by 100 to make it a percentage, we find that there were 3.8% more women than men in Canada in 2006. The rate is the number of observations in one group per round number of another. To figure out the rate, we would find the proportion in the group and then multiply by the round number in the denominator of the fraction. For example, we know from an earlier video that the proportion of women is 0.5095. If we multiply that by 1,000, we would find that there are roughly 510 females for every 1,000 Canadian residents. These types of comparisons can be more meaningful to people, especially when raw numbers are large, like in the census. Another example of using rates is this crime rate graph. This figure shows how crimes per 100,000 people changed over time. Without standardizing by the number of people in the population, it might look like crime is increasing simply because the population is growing. By benchmarking crime by population, we are making numbers more comparable over time. As discussed above, a percentage is just a proportion multiplied by 100. We don't need to belabor that any further. A percentile is the value of a variable that puts a certain percentage of observations below it and a certain percentage of observations above it. For example, we might want to know what the 90th percentile value is for a test. If it's 65, that means that 90% of the people scored lower than 65 and 10% scored higher. So 65 is the number such that 90% of the observations are below it and 10% above it. This is the definition of the 90th percentile. There are some percentiles that we sort of give special meaning to or pay special attention to. The 50th percentile is called the median or the second quartile. This is a measure of the center or middle of a set of numbers. We'll talk in coming videos about other ways that we can measure the center of a distribution of numbers. The 25th percentile is called the first quartile, and the 75th is called the third quartile. We call them quartiles because they, that is the 25th, 50th, and 75th percentile values, are the ones that break the variable into 4 roughly equal parts or quarters. We identify the difference between the 75th and 25th percentile as the interquartile range. The summary statistics shown in the slide are for the age variable from the 2015 Canadian election study. There are lots of numbers in the summary, but I want you to pay particular attention to the ones that are in the box. These are the interquartile range and 5 different percentile values. The interquartile range is the difference between the 25th and 75th percentile. The 0th percentile and 100th percentile are the minimum and maximum, respectively. And then we know what the 25th, 50th, and 75th percentiles are because we talked about them on the previous slide.